Shall we start? This is there are two sections are remaining. One is that we have looked at doctor level, but we have not looked at the institution level. The assumption that some doctors belong to some institution. So therefore, we need to see, is it really because of the doctors there is a variability, or because they are coming from the institution, therefore it is an institution variability hidden by doctors. Okay. So therefore, if there is a, this is what the multi-level hierarchical model. Okay. So therefore, if there is an opportunity to look at the higher level, we need to look at it and see the one is masking the other one. So therefore, the institution is a higher level. That is what we are going to see. So this is the structure. Basically, this is from PISC book, the institution level, and what we have looked at is doctor level. So how do we introduce this? So if you look at the variability statistics, this is from a different software. The K means institution level, and this is the error term. This is the, so you allow the intercept to vary by doctors and the doctors from various institutions. Therefore, you have residual variance and the J and K and the institution level. K means institution. J and K means doctors and institutions, and so on. So now, this is the steady variable which we are interested in studying, the age and cholesterol. And this is the constant term. The constant term has I, J, K. Please see this one. So therefore, it deals with the two more further levels. You don't count that I is the level because I is the lowest level really. So we have the doctor level and now institution level. And this is the regression coefficient, and that is a constant term, and the variability statistics, which has got further variabilities here. Now, first question is that should I look at whether the higher level institution is needed or not? I'm not very keen on that ICC. And if you do this one, this is, do you have doctor level variability? This is see here, that is the random intercept model with the doctor level, random intercept the institution level. So therefore you have J and K. It's purely random intercept model. There's no random slope here. Okay. So which gives you the log likelihood 404. I remember the 404 for which model? Do you remember? Doctor's level? Yeah. So no change absolutely between random intercept at the institution level and random intercept level. But we need to study the change. This is model A. This is the doctor level, random intercept and slope. Do we need random slope at higher levels? So first of all, the question is, do we need a random intercept at the higher level at all? Okay, that is something which need to be resolved. Here, the next question is, this is random slope at higher levels. Model A, we allow, this is a doctor level, this is doctor and institution level. If you compare these two models, you'll address the question whether you need random slope at the higher level or not. Okay. And this is model A. The likelihood is 789, say for example. And model A is what? Model A is your random slope at the doctor level. Model B is, that is what you get here. So you have the random intercept at the institution level, and this is the slope, random slope. So now this is 300, 399, yeah, 399, and so model B is basically that slope running at in doctor level and institution level. And you see here a lot of zeros, which means the model is not converging there. There's no point in adding a random slope for institution level. That is the message here. The variances are 0, 0, 0. It implies that the model is not able to run and give the estimate. So therefore, let us not worry about the institution level slope. I don't know whether we have resolved on whether we need a random intercept at the institution level or not. Okay. So this is random slope for age at both medical doctor and institution level. So based on this random slope, isn't it? The random slope for a medical doctor at the institution level. This is what we got here. And that is not coming out very well in this analysis. It suggested that the overall analysis is that you don't need institution level. So this is the exercise, just I wanted you to see whether you can do that exercise and you get the same results as projected here. And see, there's no, but if you look at the 0.005, the standard error had increased very much. So previously we have seen 0.00, this is the random slope at the medical doctor level. Absolutely, there's no change between the standard error or the estimate between random slope, random medical doctor level and the institution level and random slope. So this is from a different software, so I don't want to use the slide. Just wanted to clarify the model for using that equation. So this is random slope. This is random slope, random intercept at the medical doctor and institution level with the random slope. So this is 399, and the standard error here for the age is 0.005. So let us go back and see. This is random institutional random intercept both medical doctor and institution level, and random slope for age at the medical doctor level. So there's a difference between the two. The later model introduced institution level also slope. And it suggested that if you look at the data, that this model 0.05 is the regression coefficient and 0.005 standard error. And this is likelihood is 399. And here also 399, and same values at the institution level also. The intercept slope was introduced at the institution level. So absolutely there is no change in the data, the estimates. So therefore we strongly believe that the institution level analysis is not necessary. Okay, so that is the conclusion which we have. I wanted you to see whether you are able to run this code and see you can bring in a higher level. Then we will move on to it. Yeah. 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 Correct. Correct. That is why it is called a hierarchy. Mixed effect model, hierarchical model, multi-level model. And can you please do this exercise and we will follow you. This is to